All right, you guys, we're going to continue our discussion on rational functions. The next thing we're going to be looking at are asymptotes. So you may be asking, well, what is an asymptote? Well, it's a line that a curve approaches as it heads towards infinity. Okay, so there's three different types of asymptotes that we're going to look at. We're going to be looking at horizontal, vertical, and oblique asymptotes. Okay, so a horizontal asymptote looks just like a horizontal line. So right here, these are your two cases for horizontal asymptotes. You'll notice that when we draw them in, we use dashed lines. Okay, also, if you're trying to draw these functions on a calculator, you're not actually going to see the asymptotes, but it's going to look like your function is approaching some imaginary line that it may or may not cross, okay? These two cases here are your vertical asymptotes. So you'll notice that they have these pink dashed lines that are going in a vertical direction. So those are two of our asymptotes. The last kind of asymptote that you have is an oblique asymptote. And depending on what book or resource you're looking at, sometimes they call them slant asymptotes. So different name for the same type of asymptote. Okay, so it's important that not only can you recognize those asymptotes when you're looking at a picture, but do you know how to find them? Okay, so the ways that we find those asymptotes are labeled here in this table. So the first one that we're going to look at are vertical asymptotes. Okay, so if they ask us to find vertical asymptotes, what you're going to do given your rational function, you're going to set the denominator equal to 0 and you're going to solve for x. Okay, so your answer for your vertical asymptote is always going to be in the form x equals a. So it's an equation for a line, needs to be in a line form, so x equals a. So what this would look like is if you had like r of x equals x plus 5 over x plus 6. If I'm looking for the vertical asymptotes, which you'll notice that I abbreviate them VAs, I'm going to set my denominator equal to 0. I'll solve for x. And I would say that, yes, this graph has a vertical asymptote when x equals -6. Okay, so to find verticals, make sure that your rational function is in lowest terms, set the denominator equal to 0, and solve. Okay, the next type of asymptote that you have is a horizontal asymptote. So let me change my color. All right, so a horizontal asymptote, there are two different cases. So if your function falls into either case 1 or case 2, it's going to have a horizontal and you need to follow those steps. So the first case is if the numerator has a lesser degree than the denominator, then the horizontal asymptote is y equals 0. So this would be something that looks like this. If I had r of x equals x squared plus 2 over x cubed plus 6, something like that. So when you're looking at the degree, remember the degree is the highest exponent that you see, and you're going to look at the numerator and the denominator individually. So in this case, the degree of the numerator would be 2, okay? And the degree of the denominator would be 3, okay? Now, since the degree in the numerator is smaller, this function automatically has a horizontal asymptote, and that horizontal asymptote is when y equals 0 automatically. So there's no work involved. Once you see that the degree in the numerator is smaller by 1, notice that this difference is that 2 is only less than 3 by 1. Automatically, you have a horizontal asymptote, and automatically it's at y equals 0. So all you have to do is be able to recognize that. Now, case 2. Okay, so if your function doesn't fall into this first scenario that we talked about, maybe it falls into the second case. So that happens when the numerator and the denominator have the same degree. Then you will also have a horizontal asymptote, and the horizontal asymptote is going to be at the ratio of the leading coefficient. This is what we mean by y equals a subscript n, b subscript n. Okay, so that would be an example like r of x equals 2x squared plus 3, 3x squared plus 4. My degrees are the same, so my horizontal asymptote is going to be at y equals 2 over 3.